Good morning, everybody. Let me know if you can hear me okay. Thank you. All right, we're going to start today with a do now. Most of the time, we are going to start with a few review questions. If you didn't have a chance to do this, if you just logged in, that's okay. We're going to go through it, and then you can let me know, oh, I didn't get that one, or can you go over that again? That kind of thing. All right. Question 1. Is the measurement 1,685.70 milliliters a length, volume, or mass? You can just put L, V, or M in the chat. It's a volume. So liters, that's your clue. How many significant figures? Oops. This is supposed to say 1685.70. It's supposed to be the same number. Dr. Hefner's struggling this morning. How many significant figures are in 1,685.70 milliliters? So in the other number, there would have been 5, but there's 6 here. So this 0, that is actually significant. Zeros at the end of decimal numbers are significant. All right. Now, how do we write this number in scientific notation? So we don't have to round anything. We're going to use all of these numbers because they're all significant, right? So our coefficient is 1.68570 because that 0 is significant, times 10 to the third milliliters. So in your coefficient, you want to have all the significant digits. It's not okay to round if the question doesn't ask you to. Here it just said write this number in scientific notation. So that means that your coefficient should have all of the significant digits. And don't round unless directed to. So if you're answering a question where you have to use the correct number of sig figs, you always round. But if the question is simply write this number in scientific notation, you want to keep all the significant figures in your coefficient when you're writing scientific notation. So are we good with these? This is just a little bit of a review. We didn't do any of the adding and subtracting and stuff, but when we are gearing up for exam 1, we'll circle back around and do some of that and kind of refresh. So are we ready to move on to chapter 2? Okay, so we're starting chapter 2 today. I posted the, oh, we have another question. So this number here, it's not negative because our starting number, the standard number, is at least 1, right? And when our standard number is at least 1 or more, then the power of 10 is going to be positive. Does that answer your question? Okay. Oops. Going ahead of myself. So we're starting chapter 2. I broke it up into 2 weeks to cover this. I traditionally try to cover this chapter in 1 week, but it's just so much information. And I think that you guys will do better if we're able to spend a little bit more time problem solving with this first part. And then we'll do the second part next week, which the video will be posted for you. And you won't have mastering chemistry due this weekend. It will be the following weekend. You will still have an assignment. It'll be a chapter 2 check-in and also the syllabus quiz, both of which will be posted today. So first we're going to do a quick little fill in the blank. If you didn't get a chance to watch the video, you might be a little bit struggle busting through the lecture because I'm kind of assuming that you've at least had a chance to glance over it. So here's a table that I had in the video, and I just want to take a second, and I'll give you probably 2 or 3 minutes to fill this in from your notes, and then I'll go over it. So you're going to fill in the different physical quantities, the basic units used, and the symbols. And this table will be helpful for you when you're doing problems, when you're trying to figure out what basic unit you should use to describe whatever physical quantity you have, like a volume or time, things like that. So I will give you 2 minutes to start filling this in. Then I'll hop back on and start filling it in. Alrighty, I'm going to start filling these in. So for the first row, the basic unit is a meter. The physical quantity associated with that is length. And the symbol for meter is a lowercase m. For volume, the basic unit is the liter, and its symbol is a capital L. The symbol G is for gram, and that's what's used to measure mass. And finally, time is the second, and its symbol is a lowercase s. We'll be using all of these throughout our problem solving today, and they will kind of always keep coming back throughout the rest of the course. So remember your symbols and your basic units. Any questions here? You can say yeah, nah, ask your question, or we can move on. Okay. Not doing anything too terribly difficult yet. So this chart is in your textbook, and I talked about it in the recorded video. This chart will be very, very handy for you. You will get to have this chart for your exam. I will not make you memorize all of the prefixes for the metric system, but you need to know how to use this chart. In the first column, you've got all the prefixes, right? Second column, all the symbols. And then the third column is what each of these prefixes means. So there are some prefixes that increase the size of your basic unit and others that decrease. If I use, for example, kilo and put it in front of meter, What that means, here's kilo, is that I have 1 times 10 to the third meters. Notice how I can replace the kilo with the number from the chart. Let's do another one. Let's say that I have micro. That is the sign for micro. It's got a little tail. Let's say I had a microgram. Find micro on the chart and tell me what the scientific notation is. What does micro mean? One times 10 to the minus 6. So does everybody see how to use the chart? All right. Then let's try writing some unit equations, okay? Because that's essentially what we were doing on this other page. Now, unit equations, if you didn't get a chance to watch the video, I'll try to catch you up really quickly. A unit equation pretty much relates two units of measure. They have to be equal. So if I have 1 cup, right, like a cup of water, that's the same thing as saying I have 8 ounces of water. Fluid ounces if we want to be real particular. That's the same type of thing that we're doing, only with the metric system. So let's do a couple of these. I'm going to do the first one, and then I'll let you do the other two. We need to write a unit equation to describe the relationship between centimeters and meters. I find centi on the chart. If I have 1 centimeter, it's equal to 1 times 10 to the minus 2 meters. Simple as that. The other way that you can write this is if I have 1 meter, then I have 100 centimeters, which is the same as 1 times 10 to the 2. They both mean the same thing. I want you guys to give number 2 a try, and then we'll come together and see how we're doing. I'll give you a minute to write a relationship between kiloliters and liters. Okay. Anybody have an answer for number 2? Oh, you were ready. Yeah. 1 kiloliter is equal to 1 times 10 to the third liters. The other thing that you could have is 1 liter is equal to 1 times 10 to the minus 3 kiloliters. Okay? Those two unit equations describe the same relationship, but it's much easier to get this top one from the chart directly. What about number 3? No, you are not required to do both. I try to put both just so you see both, and sometimes some people naturally gravitate towards one or the other. So I want to make sure everyone knows there are two ways to do it, but you're only required to know one. You're very welcome. What about number 3? We've got nanograms and grams. We've got the same relationship with each of these pairs of unit equations, but you only need to have one. Are there any questions about writing unit equations using the chart? We're going to have more practice, so if you just need practice, that's fine. Okay. Now we need to write unit factors. Unit factors you may also see called conversion factors. Same thing. So if you're looking online for help, conversion factors and unit factors are the same. And they pretty much take the unit equation and you write it as two fractions. You need to know the difference between the unit equation and the unit factor. Unit equation has an equal sign. The unit factor looks like a fraction. So if I were going to write the unit factors for this first unit equation, I'd simply take one of those numbers, so I'll start with the 1 centimeter that's in the numerator, put the other number in the denominator. That's a unit factor. To get the second one, you just write the reciprocal. So you put the denominator in the numerator, and you put the numerator in the denominator. I'll do the second one for you. It's a pretty simple concept. It's much easier than doing the unit equations. So does everybody get that? That's how we get unit factors from unit equations. I'm not going to have you practice that right now. We're just going to jump into some problems. So let me know. You ready to jump into problems? Or do you need a little help? Yeah, we can wait. I'm so grateful y'all are responsive even at an 8 a.m. class. Because sometimes it's a struggle. Let me know when you're ready. All right. So unit equations and unit factors, all that information is so that we can do metric conversions. We're going to go through this problem together, and then I have another similar problem that I'll let you do on your own. And that's how we're going to run this for the rest of the time. I've got multiple problems of the same flavor. I'll do one. Y'all will do one. If y'all are good, we move on to the next topic. If you're not, maybe we'll do a little more practice. So here, We're performing an experiment that requires 56 milligrams of sodium bicarbonate. Your balance reports mass in grams. How many grams of sodium bicarbonate do you need? Report your answer in scientific notation. When problem solving, I always use kind of the same overall method. I rewrite the question if there's a lot of words, and this is there's a lot of words around here for a very simple question. I write down what I'm given and any equations that I know that relate to the given information. Then I use all of that to set up my equation to solve the problem. So our question here, we've got 56 milligrams. And we're trying to figure out how many grams that is. Our given information, obviously, we've got 56 milligrams. But we also know something about the relationship between grams and milligrams. If I have 1 milligram, then I have 1 times 10 to the minus third grams. That's my unit equation. From there, I can write 2 unit factors. Now I've got all my given information laid out. I can write out an equation. Starting with 56 milligrams, I need to choose one of these unit factors that will get me from milligrams to grams. I've already got milligrams in the numerator. To cancel out milligrams, I need milligrams in the denominator. So I will choose the unit factor with milligrams in the denominator. Then I go through and make sure that my units make sense. We're canceling out milligrams, ending up with grams. I look back at my question. Is that what I'm looking for? Yes. Then I get out my calculator. And there's my final answer. So that's the process for solving these problems. Questions, comments, concerns? Or are you ready to try your own? Okay. So let's rework this problem. Let's say that instead of 56 milligrams, you need to take 56 nanograms and figure out how many grams you have. Now I'm going to ask for some input. I'm going to go back so that we can see that table. And I want you to figure out what our unit equation is. So we're doing nanograms and grams. Yeah, we already kind of did this one. So that's the information we're going to use. We've got 1 nanogram is 1 times 10 to the minus 9 grams. That's our unit equation. What are my unit factors? And you can use a little shorthand for this if you want to when you're trying to put it into the chat. Or you can just take a second to write it down, and then I'll write it out. So if you don't feel like typing it in the chat, I understand. I feel you. But we need those unit factors. Yep, that's 1. Yep, and then you flip it around. Yeah, I wouldn't have typed that out in the chat. I'll be honest. If I was a student, I would have been like, somebody else will do it. That's too much to type. All these weird characters. So we've got our unit factors. Now we're ready to choose one. I'm going to label these A and B. Which unit factor do we need to use? Yes, we need to use B. We need to cancel out the nanograms. We've got nanograms in the numerator already with our 56 nanograms here. We need nanograms in the denominator so we can cancel those bad boys out and be left with grams. Now I want you to try putting that in your calculator. You need to know how to put scientific notation into your calculator. Why did we choose B? We chose B because it has nanograms in the denominator. And we're trying to cancel out nanograms. So remember, like in math, if I was doing 5x times 3 over x, I can cancel out those x's, right? And then it would just be 5 times 3. That's exactly what we need to do here. We need to cancel out the nanograms so that we're left with grams. How do I know to divide the two numbers? So there's a question in the chat. I want to get to that first. Morgan, so can you give me a little bit more about that question? I don't quite understand what you're asking. So that's part of recognizing the problem type. When you're doing this, when you're doing conversions, all you're doing is multiplying by a conversion factor. So you're multiplying by something and dividing by something. That's just how conversions work. So take my word for it. Does that make sense? And if not, that's okay. If not, that's okay. But that's how we know, okay, I have 56 milligrams or 56 nanograms. I need to find a conversion factor to get me from where I am to where I need to go. And that conversion factor means that you're multiplying and dividing, always and forever. And there was another hand, and now there's another hand. So whoever was first, ask your question. Yes. So depending on your calculator, what you would have to do is 56 times. Now, if you have like kind of a TI 89 or 83 or something like that, it would be 1, and then there's an EXP button that you would hit, and then you put in -9, and then the equal sign. Some calculators have an EE button for exponents. Same thing. I saw another hand before. Yeah, for some calculators you need to put parentheses, some you don't. For the 83 and the 89 you do not, but it depends on your calculator. You can put parentheses around it for any calculator and it should work. Well, if you successfully get it into your calculator, that's what your answer should be. Remember, we're supposed to answer using scientific notation. Oh, and I didn't do that before. See, that's my bad. I would have gotten points off. Other questions? Then I think it's time that y'all try one. So here's a simple one, or at least it doesn't have as many words. How many milliliters are in 1.82 liters of water? Remember that you need to have a unit equation that you write unit factors from. Once you have that set up, then you can write your equation. But don't just go straight to your calculator. Get in the habit of writing out your plan, kind of what you know, setting up your equation, checking your units, and then using your calculator. So I will give you a 3-minute head start. If you get stuck, you can put "I'm stuck" in the chat. I'll help you out. Otherwise, in 3 minutes, I'll get started solving the problem. How are we doing? Do we need more time? Are you stuck? Talk to me. Okay, I'll give you a little more time. I'll give you another 2 minutes, and then I'll start solving. Okay, if you need help setting it up, then I can slowly go through that. And then that'll allow the folks who are still working a little more time. So what we're given is 1.82 liters. Our question, we need to know how many milliliters that is. The relationship between milliliters and liters. If I have 1 milliliter, that's 1 times 10 to the minus 3 liters. That's my unit equation. Does that help with setting it up? Mm-hmm. Okay. Well, we'll get there. Should get the same answer if you say 1 liter or 1 milliliter. And I can go through and show that too, and I'm going to do that. We'll solve it this way first, then I'll write the other unit equation and show how that works as well. So there are my 2 unit factors. Now I've got a decision to make. Which one of these unit factors do I choose? I need to cancel out liters. I have liters in the top, the numerator. I need liters in the denominator. That means I need A. Because watch. Liters, you need 1 on the top and 1 on the bottom to cancel. Does everybody see that? Okay. Yeah, if you did yours the other way, then you're gonna, I'll show you that way too. Okay, yeah, not a problem. So now, if you put this into your calculator, it's 1.82 divided by, what in the world? Oh, why'd you do this? There. Weird stuff always happens when I try to write at the bottom of the screen. You'd think I'd learned my lesson by now. No, I try to use every drop of the screen. Anyway, back to our regularly scheduled programming. You're going to put in 1.82 divided by, and you can use parentheses, 1 exp negative 3 and the equal sign. You can also, since this is a pretty small number, you can just put in 0.001 instead of the scientific notation. Either way, you get that, but we need to write it in scientific notation. So does everybody see that way how we solved it? I'll go through and do the other unit equation just to show it's the same. So let's think about it this way. If I had a pizza, right? Usually it's divided up in, let's say this one is divided up into 6 pieces because I can't draw. All right. This is one pizza. One pizza is equal to, in this case, 6 slices. Pizza, that's a bigger unit. Much bigger than a slice, which is pretty small. So if I had 2 pizzas, how many slices would I have? In this case, I'd have 12 slices. The number gets bigger, right? What if I went in the reverse? Let's say I had 18 slices. Well, the number of pizzas that I have is going to be smaller because pizzas are bigger units. It's the same thing. If I have 1 liter, 1 liter is bigger than a milliliter. So if I'm going from a bigger unit to a smaller unit, then I need to have a positive exponent in my scientific notation. SN is scientific notation. So if that, for some people, this way makes sense to say 1 liter is 1,000 milliliters. For others, you just read it straight from the chart. So if this second way confuses you, just pretend that it doesn't exist and go la 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 with your fingers in your ears for about 30 seconds. As long as you understand one way, you're good to go. So I don't want you to be confused by this. It's just that some people solved it this other way, which is also correct. Mm-hmm. Why did we divide 1.82 instead of multiplying? So it's just because of how this first one was set up. If you have a number in the bottom, then you divide. If you have a number in the top, you multiply. You're welcome. So I want to point out the units for both of these unit factors are the same. Yeah, if you want to go the other way, so we went from small to big on the left side. And we had a negative exponent. If you flip the order, big to small, then you need to flip the sign. But you don't have to, as long as you know one way, if one way makes sense to you, that's fine. You don't have to understand both. I went through the second way because I know that there are some folks who solved it this way versus the first way that I solved it. So don't confuse yourselves like, well, wait, I don't understand the second way, or I don't understand the first way. As long as you understand one of them, you're okay. We're going to do some more. So the next step is to build on this, where instead of doing just one of these conversions, we're doing two. So we're going to continue to work on this. And we're just going to build a little bit. So there's also metric to English conversions. This is still just one conversion factor that you're going to use to get from point A to point B. But instead of it being metric, you have one metric unit and one English unit. For these, you don't have a chart. So if I give you this kind of a problem on an exam, I'm also going to give you the unit equation. So the speed limit on a road in Canada is listed as 150 kilometers per hour. Express the speed limit in miles per hour. And I've given you the unit equation already. So I'll give you 3 minutes to get started, and then I'll just jump in and start solving it. In the interest of time, I know that we're going to have to kind of not push through it, but I can't give you as much time as I would like to solve each problem. So get as far as you can in 3 minutes, and then I'll jump in. I'm going to set this problem up here. If you're still working, that's fine. Our question, we've got 150 kilometers per hour. We want to know how many miles per hour that is. We're already given the unit equation because that's not something that you can just figure out. They're not even from the same system. So I think most of us can get through those unit factors. But setting up the equation is where things get a little bit iffy. So which unit factor am I using? A or B? Yes. We're going to use B. We want kilometers in the bottom. You cancel that out. And we've got miles in the top. So when you put this into your calculator, it's just 150 divided by 1.61. Anybody get an answer? What does your calculator say? Yeah, so the calculator says 93.167 blah blah blah. We can only have 2 sig figs because the 150 kilometers per hour only has 2 sig figs. With these metric to English and English to metric conversions, you will have to consider sig figs and rounding, just because it's not going to be a pretty even number with the same number of scientific or of significant figures at the end. The metric works beautifully. Metric to English, kind of messy. So we're going to retain this 3 because that's going to be our second significant figure. We're going to look at the 1 to see if we need to round it. 1 is definitely less than 5. So we're going to go with 93. But we need units. What are the units? Resist the urge to use M for miles. At the very least, use MI, because you don't want to confuse it with meters. But it's 93 miles per hour. That's pretty fast. Questions about how we did this? It's the same method as before. Do we feel a little bit more comfortable than the first problem? Talk to me about how you feel. The goal here is to feel better than you did before. So with each problem, hopefully we're building a little bit. Say, okay, I think I know a little bit better. I think I understand a little bit better. You're still going to have to do the work at home. Do the homework, do some practice problems, that kind of thing. So here's another metric to English conversion. A bread recipe calls for 740 grams of all-purpose flour. How many ounces of flour do you need? And I gave you the unit equation here. I give you another 3 minutes, and then I'll solve it. I'm going to jump in here and start solving. The question we need to answer, we've got 740 grams. How many ounces is that? We're given the unit equation, which makes life easier. 1 gram is the same as 0.035 ounces. You know what I'm about to ask. Which one are we using? A or B? Keeping in mind, we've got to go from grams to ounces. Yeah. We need those grams in the bottom. Always check your units. It may seem a little silly to do when we've only got one conversion factor, but we won't always just have one. So get in the habit of checking. Now all you have to do is 740 times 0.035, and that should give you an answer. Your calculator is going to tell you 25.9. But we need to consider sig figs. 740 grams. How many sig figs are in 740? There's 2 sig figs here. So what should our answer be? 26 ounces. Time to check in with y'all. How are we feeling about these conversions? Do we feel a little better than the last problem? Good. Because now we're going to get a little harder. We've been doing one conversion. Yes, I always record the live lectures and put it up on YouTube, and I put up the notes. So everything that I'm writing, you will have available to you as a PDF. Makes your life a little easier, I hope. We're moving on to 2 metric conversions. What this means is that you have to use 2 unit factors to get from A to B. So we're going to have 2 unit equations and 2 unit factors. How many nanoseconds are in 5.21 kiloseconds? Report your answer in scientific notation. We're starting with 5.21 kiloseconds. And we're saying, how many nanoseconds is that? Notice, for each of these, there's a prefix. When you see a prefix on both sides of the equation, you can't just jump from one to the other. We've got to go from kiloseconds to seconds, and then from seconds to nanoseconds. That's why we have 2 unit equations. Our first unit equation is going to be going from kiloseconds to seconds. If I have 1 kilosecond in kilo is 1 times 10 to the third. That means I have 1 times 10 to the third seconds. If nano is 1 times 10 to the minus 9, what's my second unit equation? That's going to be our second unit equation. We've got 1 nanosecond, and that's equal to 1 times 10 to the minus 9 seconds. Now we write our unit factors. That's the easy part. Now we set up our equation. Let's look back at our plan. We're starting with kiloseconds. And with this first unit factor, we're trying to get to seconds. From there, we're trying to get to nanoseconds. We've got to use a unit factor from our first unit equation. Are we going to use A or B if we're trying to go from kiloseconds to seconds? We use B. It has kiloseconds in the denominator, and that's what will cancel out kiloseconds for us. Now we need to choose again. This time we're going from seconds to nanoseconds. Are we using A or B? We need A. Let's make sure that our units make sense. The first step, we're getting rid of kiloseconds, and we should end up with seconds. We do. The next step, we get rid of seconds, we end up with nanoseconds. And that's what we want. I want you to try to put this into your calculator and let me know what you get. So here's how you know. If it's a number on the top, you're multiplying. If it's a number in the bottom, you're dividing. So what you would do for this one is 5.21 times 1 times 10 to the third divided by 1 times 10 to the minus 9. You're welcome. Sure, one more time. When you have a number in the top of your unit factor, you're going to multiply. When you have a number in the bottom, you divide. For this equation, what you're entering into your calculator is 5.21 times 1 times 10 to the third divided by 1 times 10 to the minus 9. You're welcome. Try that out. Let me know what you get. Yes. 5.21 times 10 to the 12 nanoseconds. Now let's make sure that makes sense. We've got 5.21 kiloseconds. Kiloseconds is definitely bigger than nanoseconds. So that means our number should be much bigger than what we started with. And something times 10 to the 12th is certainly pretty big. So that makes sense. Always check with your logic. Make sure your brain says, yeah, that could work. Because if you got, say, to the negative 12, then you could know, okay, that's wrong. That can't possibly be right because the number of nanoseconds should be bigger than the number of kiloseconds. If you think about the pizza analogy, the kiloseconds, that's the whole pizza. The nanoseconds are the slices. The number of slices you have should be much bigger than the number of pizzas you have. Let's try another one of these. An experiment requires 25 picograms of enzyme. How many milligrams of enzyme do you need? Report your answer in scientific notation. I will give you the information from the chart. Pico is that. And milli is that. I will give you 5 minutes to kind of write out your information, get your unit equations and unit factors together, and then I'll jump in and start. You can continue working and try to put that equation together. And if you get to an answer within that 5 minutes, feel free to put it into the chat. If you don't, it's okay. but 5 minutes, and then I'll start working. I'm going to start setting up the problem here. For this problem, we know it's a 2 metric conversion problem. And the reason is you see a prefix on both sides of our question. We've got 25 picograms, and we need to figure out how many milligrams. We have to use 2 conversion factors here. The first one will get us from picograms to grams. And the second one will get us from grams to milligrams. If I have 1 picogram, that means I have 1 times 10 to the minus 12 grams. I write out my unit factors, which are just the fractions. And I do the same thing for my second unit equation. This time we're taking grams and going to milligrams. If I've got 1 gram, that equals 1,000 milligrams. I could also write it as 1 milligram is equal to 1 times 10 to the minus 3rd grams. They're the same thing. I'm going to go with this unit equation here and write some unit factors. Now we've got to do the equation. We've got 25 picograms. And we're going from picograms to grams to milligrams. To go from picograms to grams, which unit factor am I choosing, A or B? I'm going to choose B. We've already got picograms in the numerator, that's the top number. I have to have picograms in the denominator, or the bottom, of my unit factor to cancel it out. To go from grams to milligrams, which one am I using, A or B? We sure about that? We need to have the grams in the bottom. So it's going to be, you got to pay attention. It all depends on which way you set up your unit equation, whether or not it's going to be A or B. So you got to watch. Always check for your units. We were looking for the grams in the bottom, and that's B. We go through and double check. Our picograms cancel out to give us grams. That's what should happen with the first unit factor. In the second one, we're canceling out those grams, and we're left with milligrams, which is what should happen. So, if you didn't get an answer, that's okay. You can try it now. 25 times 1 times 10 to the minus 12 times 1,000. Let me know what you get. And if you already got an answer, you can put that in. Yeah. You should get 2.5 times 10 to the minus 8 milligrams. So does this problem feel a little bit better than the last one? Getting there. It's a process. All right. We're going to do one more problem type, and then we'll take a short break. Compound unit problems. These are similar to the two metric ones. We'll need 2 unit factors, but we're changing a unit in the numerator and the unit in the denominator. I'll do this problem for you. We've got one more after this, and then we'll take a break. The average low-flow shower head flows 3 gallons of water per minute. What is the flow of water in liters per second? Now, you're not going to know how to convert from liters to gallons just using, the chart that I gave you. You're going to have to ask Google. But 1 liter is equal to 0.26 gallons. We've got 3 gallons per minute. This is compound units, all right? Kind of like miles per hour or kilometers per hour. Those are compound units. And what we need to do is figure out what that means in liters per second. So we're changing the gallons to liters and the minutes to seconds. The first unit equation is going to deal with changing the gallons to liters. And like I said, you're not going to know that just by looking at the chart. That's something I have to give you. So that part is done. It was pretty much done for you. Unit equation number 2, we're going from minutes to seconds. Now that's not something that you're going to see in that chart for the prefixes, but it is something that you know. How many seconds are in 1 minute? There's 60. That's a unit equation. Now we need to be very careful with our units here. To go from gallons to liters, which unit factor are we going to use, A or B? Remember, we have to cancel it out. So if gallons are already on the top, we need gallons in the bottom. The only one that's got gallons in the bottom is B. Now we're going to do a little something different. This next conversion factor, we're going from minutes to seconds. But notice we have minutes in the denominator. To cancel out minutes, we need to have minutes in the numerator. So we need to use A in this case. Because at the end, we want to end up with liters per second. The gallons cancel out, and we've got that. This is almost like doing two separate problems. We've got minutes that we need to cancel out, and we've got liters per second, like that. When you put this into your calculator, You're doing 3 divided by 0.26 divided by 60. Try that out. Let me know what you get. Your calculator is going to tell you 1.192 something something something. Sig figs. We're given 3 gallons per minute. That's only 1 sig fig. So we need to round this to 1 sig fig. We got to round the 1, look at the 9, see whether we round up or down. So that's 0.2. For our units, it's liters per second. Remember, the question was, how do we go from gallons per minute to liters per second? So liters per second better be the units for our answer. I'm going to go through one more of these compound unit problems, and then we'll take like a 5-minute break, because I'm sure your brain is about to explode, and I'm sorry. Chapter 2 is like a little bit heavy after we come off of the prerequisite science skills, but that's chemistry for you. So it looks like we're back in Canada. The speed limit on a road in Canada is listed as 150 kilometers per hour. Express the speed limit in meters per second. So remember that M is meters, not miles. We're going from meters per second. So here's what we've got to do. The first thing we need to do is go from kilometers to meters. Then we have to go from hours to seconds. If kilo is 1,000, what's my unit equation if I'm trying to go from kilometers to meters? Give me a unit equation for that. Don't everybody answer at once. We're probably getting a little burned out, so I'll help you out here. Yeah, 1 kilometer is equal to 1 times 10 to the 3rd meters. So for our second unit equation, we're dealing with the time. We have to go from hours to seconds. But we can't just jump there. We actually have to go through minutes. So hours to minutes, 1 hour has 60 minutes. And our third unit equation will go from minutes to seconds. And we just did that in the last problem. So we've got 3 unit equations that we need to deal with. First, going from kilometers to meters, those kilometers need to be in the denominator. Now we're dealing with the hours to seconds, and that's going to take 2 conversion factors. First, we're going to go from hours to minutes. Since hours are in the bottom, to cancel it, we need hours in the top. Now we're in minutes. We need to get rid of those minutes and be left with seconds. And if we write our plan, let's cancel out some units. We've got meters. That's going to carry through the whole way. Then we cancel out the hours for minutes. Good. Then we cancel out the minutes for seconds. And you want to make sure that you've got meters at the top and seconds on the bottom. So that's the other part of our check. Not just do we have these units, but are they in the right place? Now we can go ahead and touch the calculator. Doing 150 times 1 times 10 to the third divided by 60 divided by 60 again. Try that in your calculator and let me know what you get. So we get 41.6 repeating, right? 150 kmh, that's 2 sig figs. So that's right, we need to round to 42, and the units are meters per second. Compound units sometimes takes a minute to wrap your brain around. We'll do another practice like that next week as part of our Do Now. You'll probably have one of these on your chapter check-in. I think you do. So, you'll get to practice. Here's the dilemma. It's 10 o'clock. Do we want to keep going, or do we want to take a 5-minute break? If we keep going, we might end a few minutes early. If we take a 5-minute break, we'll be going all the way up to 10:30. Let me know which one you want to do. We got to vote for keep going. All right. We'll keep going, and then we'll probably end a few minutes early. All right. The last concept we're going to cover this time is percentages. A little bit easier. Shake your brain out. We're going to relate it to exam grades because I'm sure that's something you're familiar with. We all are. A student scored 87.5 out of 115 possible points on an exam. Calculate the student's grade as a percentage. When we're talking about percentages, we're talking about a part over a whole times 100%. So if I were going to calculate the percentage for this student's grade, I would take the 87.5 points divided by 115 and multiply by 100%. Since we've only got 3 sig figs here, that would be my answer. Your calculator would say 76.086 something something something. Is everybody good with that? Because that's something that I think most of us should kind of remember and know and understand how to calculate a percentage. So let me know. Is that good? Okay. Then let's try this one. A student earned a grade of 92% on their second chemistry exam. If the exam was graded out of 115 points, how many points did the student earn? It's a little bit more difficult, but we can still do it. This time, if I fill in everything that I know, the student scored 92. We don't know how many points that equals, but we know that it's graded out of 115 points. And that you always multiply that by 100%. I want you to take 2 minutes and solve this equation to figure out the part. How many points did the student earn? If problem solving like algebra is a problem for you, that's okay. Well, it's good to know now, and then we can solve that issue for you. So go ahead and solve that problem, and then I'll check back in. Did we get an answer, or do we still need a few more seconds? Okay, I'll give you another minute. I'm going to show you how to start solving it here, and if you get an answer, feel free to put it into the chat. So to solve this, we have to isolate the part on one side and everything else on the other. So you can treat the part like x, okay? The first thing we're going to do, I'm going to change colors here, is multiply everything on both sides by 115. What that does is gets rid of that 115 in the denominator. The second step is to divide everything by 100%. Now you've got the part on one side, which is the number of points, and a number on the other. Now in this case, we've got 2 sig figs in our percentage. So if we were going to do sig figs here, it'd be 110, okay? I would tell you how to round for this kind of a question. I would let you know if I want you to round or not, how many decimal places, that kind of thing. How was that for you guys? Okay. We've got one more. The Earth contains 4.7% iron. How much iron is in a 71-gram sample? A percentage, we can actually write it out what it really means. It means 4.70 out of 100. That's what a percentage is. And in this case, we're talking about 4.70 grams of iron in a 100-gram sample. That looks a lot like a unit factor. We can use it like one too. If I have 71 grams of sample, I can multiply by my unit factor. That way we can figure out how much iron is in the sample. Now don't forget, when you're doing this, you multiply by the number in the top, divide by the number in the bottom. On your calculator, you need to put in 71 times 4.7 divided by 100. If you don't do the divided by 100, you will get a stupidly large number, and it won't make sense. Try it out, let me know what you get. That's what your calculator says. We've got 2 sig figs here and 3 sig figs here. So our answer's got to have 2 sig figs. And we need units. We've got grams of iron. Questions about this one? Then that's it. Let your brains rest and give you a few extra minutes if you have a class at 11. So I'm posting a Chapter 2 check-in and the syllabus quiz today. They are both going to be due Sunday, February 7th. The syllabus quiz, you will find it on Blackboard in the course content folder. The Chapter 2 check-in will be in course content in the Chapter 2 folder. What you will do is do your work. You can either write it out by hand and then take a picture of it and upload that picture to Blackboard to the assignment. Or I will be posting both the PDF and the Microsoft Word versions. So if you so choose, you can type up your work and then submit it that way. But make sure that you submit your work as a PDF. If I can't open your document and grade it, you won't get a grade. It'll be a 0. I will let you know, hey, can't open it. You need to resend it by this time to get a grade. If you don't, then it'll stay a 0. So if you see a 0 as your grade for this when I grade them, chances are I couldn't open your document. So don't get rid of it. Don't delete it. Make sure that you get a grade for your assignment before you get rid of your, your electronic copy. The syllabus quiz will literally be using the syllabus to answer questions to make sure that you are familiar with certain dates and how the class is run. Your Mastering Chemistry Chapter 2 assignments are not due until February 14th. I'm sorry, it's Valentine's Day. Tell your boo, I'm sorry, I got chemistry homework to do. Or you can get it done early. I would encourage you to start working on the Chapter 2 homework now because it's a lot. There's a lot of math, okay? So if you love your significant other, start your homework now so you ain't working on Valentine's Day. Your first exam is going to be available Wednesday, February 17th. That's in a couple of weeks. It's going to be on all of Chapter 2 and the prerequisite science skills that we covered last week. We'll do exam review that week, but make sure that you are caught up and you understand what's expected of you. You don't want to get hit off guard by that first exam. These exams are worth 10% each for a total of 40% of your grade. So if you mess up the first one, it's going to be a little bit harder to recover. Take the time, put in the effort, and come to office hours, which are today, 11 a.m. to 1 p.m. I'll post an announcement to let you know how to join. If you've got questions, you want to go through some of the stuff we just covered, you're more than welcome. If you have any questions, this is a good time. Otherwise, you are free to go.